Okay, these notes are on reflection of light rays and on flat mirrors and also on curved mirrors. So the law of reflection, I already have it drawn out here. You draw a flat mirror and we've got a ray coming in and then that ray bouncing off. And if you draw this line here, it's a normal line or a line perpendicular to the mirror. You see that the angle here, call it theta I, which is the incidence angle, equals the theta R, which is the angle of reflection. So angle of incidence equals the angle of reflection. And notice they're measured from that normal line. It's not the angle here, it's actually the angle here, and that is important that you're measuring that angle. Even though these two angles also would be the same, these two angles are the same. Okay. So on a flat mirror, let's say there's a person standing in front of a flat mirror with some shoes on, and we're going to look at where the image of their shoe would wind up at. Where does that person actually see their shoe at when they look in the mirror? So you'll have light rays coming off of the shoe, all directions bouncing off, but there's a particular light rays that will hit the mirror, bounce off, and go right to the person's eye. That's the light ray that the person's going to see. So if we trace that light ray back behind the mirror, we actually see where their shoe will be. Okay, so that's where the person would see their shoe, and then you can build the rest of the person off of that. So the person would see themselves, their image, behind the mirror, whereas we call this the object, the actual thing in front of the mirror. Alright, a convex mirror is just a mirror that's curved, and it's curved outwards. Let's do the same thing if there's a small person in front of that mirror. Light rays are going to come. They're actually still going to follow the rule here, angle of incidence equals angle of reflection. It's just that now the surface of the mirror is kind of, maybe if you draw like a tangent line there, is there, so it's going to bounce, and you'll see it actually bounces out. Okay, and then let's go off their shoe. That's going to hit. It's going to bounce back off at the same angle that it hit. So you can see that it's just the law of reflection. They're going to bounce out, and if you trace those back, you'll see it's actually going to be a smaller person behind the mirror. Okay, and that's just a general picture. We'll get more specific on the back side of the sheet. For a concave, it's like this. Draw a little guy. Okay, let's draw from his head parallel. That one's actually going to bounce in. You can imagine that light ray would bounce in. This light ray is also going to bounce in. So this person might be smaller. Right there. So they would see an image smaller. Oops, that's not right. Yeah, that is right. They'll see an image smaller and in front of the mirror there. Okay. Focal point, if it's convex, again curving out, we look at rays that hit parallel to the axis. So this is called the axis here. And what happens when light rays are parallel to that axis? What do? Well, again, they're going to bounce out just like they did up above. And say, draw another parallel one, that one's going to bounce out. And if you can imagine, these are all going to bounce out. But if I trace these back, and you might have to fudge it a little bit, but they should all meet up at a single point back here. Okay? And this is called the focal point. Okay? It's actually behind the mirror. And for a concave mirror, same idea. You got your axis. Let's draw some rays that hit parallel. those are going to bounce inwards, and if you can imagine, they're all going to bounce in, and they should all bounce actually to a single focal point on this side of the mirror. So just kind of fudge that drawing a little bit, try to make them all come into a single point just to get the idea that that's the focal point there, and this is obviously the focal point over there. So for a concave mirror, the focal point is actually in front of the mirror. Okay, I'm going to stop there, and then you can go to video number 2.